This is the first Forces Part 2 video. It will cover friction and the definitions that are associated with friction. This definition of friction I got offline. I did a search, came up with it, and it was the best one that I found. It's a resistance that one surface or object encounters when moving over another. So when objects slide against each other, there is friction. There is a resistance to that movement, and we call that resistance to the movement friction. There are two types of friction. There is static friction, and there is kinetic friction. Static friction resists the beginning of sliding, while kinetic friction resists sliding. So I don't know if you've ever noticed this, but if you try to push a box across the floor, it's harder to get it moving than it is to keep it moving once you've gotten it started. When you push it, before it begins to move, you're pushing against it and it's resisting your force. You're pushing, it's repelling, and it's not moving. The force that you're feeling against you is the static frictional force. It resists the beginning of motion, the beginning of that sliding between the box and the floor. Now, once you get it moving, the static friction is gone. Kinetic is a word that's associated with motion. And once you have it in motion, the friction that you feel is kinetic friction. And it resists that continued sliding of one object over another. A coefficient of friction is a numerical value that describes how hard or easy it is to slide two materials against each other. And the coefficient of friction, it depends on what the two materials are. This is something you can actually look up in a table, and there's a table of coefficients of friction in your textbook. That table would have coefficients of static friction and coefficients of kinetic friction listed together. And it would be labeled like wood on wood, or wood on metal, or rubber on concrete, or rubber on asphalt. So it's a number that, given two materials, tells how hard or how easy it is for them to slide against each other. The higher that number, the more difficult it is for them to move against each other. The symbol for coefficient of friction is the Greek letter mu. That's how it's pronounced. And the way it's written is like this. It has a little tail on the front, and it looks kind of like a cursive U. Do not say it's U. It's not U. It's mu. It's the Greek letter mu. And this is the symbol that's used for the coefficient of friction. If you looked it up, there would be a table that would say coefficient of static friction and coefficient of kinetic friction for each of these. And it would say things like wood, wood, for example. And there would be these two numbers here, because the coefficient of kinetic friction is different than the coefficient of static friction for the same two materials. The coefficient of static friction is almost always greater than the coefficient of kinetic friction. And that's why when you're starting to push this box across the floor, it's harder to start than it is to keep moving, because the coefficient of static friction, the friction that happens before it's moving, is a greater value than the coefficient of kinetic friction, which is what happens. It describes how easy it is to slide them after they're moving. Now, I haven't talked about units, and that's because the coefficient of friction is unitless. It is a ratio of two like quantities, and so their units would cancel out. And there we go. We have friction, static friction, kinetic friction, and coefficient of friction. Your book will define coefficient of static friction and coefficient of kinetic friction differently. I don't really. It's a number, describes the friction between two materials, and there's a static one and a kinetic one, and they are different. But a coefficient of friction is defined the same either way. And thank you for listening. That's the end of the first video.